Okay, so let's go ahead and take a look at these density problems. So number 1 says the density of silver is 10.5 grams per centimeter cubed. Find the mass of a block of silver that occupies 965 cubic centimeters of space. So the first thing you should always do when you're looking at these problems is underline your amounts, or at least write them out. So that will help prevent you from making silly mistakes. So density equals 10.5. And then it tells us find the mass, so I know mass is my question mark, of a block of silver that occupies 965 cubic centimeters of space. So I know that 965 is my volume, and I know that for a couple reasons. 1, that's the only thing left, process of elimination. 2, cubic centimeters is the unit for volume, so that tells me that it's a volume number. And also I know because it says the silver occupies that much space, and the definition of volume is how much space something occupies. So now that I have my numbers, I'm ready to find my formula. So I'm looking for mass. So I'm going to look down at my handy dandy density triangle. I'm going to cover up M, and what that leaves me with is D times V. So the formula for mass equals density times volume. And now all I have to do is plug in my numbers, and I know that 10.5 times 965 equals 10,132.5. So that is my mass. And it's fine for these numbers because a lot of them are going to be weird decimals if you round them up. Number 2 says a 2,750 gram sample of a substance occupies a volume of 250 cubic centimeters. Find what its density is. So again, I'm going to write out my numbers. Mass is 2,007. Oh goodness, let me erase that. Okay, here we go. Mass is 2,750 grams, and then its volume is 250 cubic centimeters. Find its density. So D equals my question mark. So looking at your triangle, or if you just know the formula, density equals mass divided by volume. So I would simply do 2,750 divided by 250, and according to my calculator, that is 11. So my density is 11. For number 3, under certain conditions, oxygen's density is 0.00134 grams per milliliter. What is the volume of oxygen if its mass is 250? So I fill in my information. Density is 0.00134. And then volume is question mark. And mass is 250. So if I'm looking for volume, I go down to the density triangle, I cover up V, and the formula that is left is mass divided by density. So 250 divided by 0.00134 equals, drum roll, it is 186,567.2. So these are some weird numbers because these are actually chemistry practice problems, but it's really good math and just really good practice. So here is your answer for number 3. So find the volume that, that's my question mark, that 35.2 grams of feathers. So if it's saying grams, I know that's mass. So mass equals 35.2. Will occupy if it has a density of 1.6. So density equals 1.6. So here I'm looking for volume. So if I go down to my triangle and I cover up V, then my formula for volume is mass divided by density. So if I do that, I have 35.2 divided by 1.6, and that equals 22. A nice, simple, pretty number. So this one has a couple of steps, but it's actually very easy. So let's start out by filling in the information we know. So we have a 100 gram block. So gram is mass, so I know M equals 100. measures 20 by 40 by 30. What's its volume and what's its density? So here my volume is a question mark, but so is my density. So I cannot use my density triangle yet, because any way you use your density triangle, you have to have at least two things of information in order to make it work. Here we only have one. But if you remember from our notes, anytime you are trying to find the volume of something such as a block, you use the formula length times width times height. So although it doesn't give us what our volume is, it does give us all the information we need in order to find that. So if you do length times width times height, which is 20 times 40 times 30, and again, order of operations, it doesn't matter what order you do that in, then your volume is going to equal, your volume is going to equal, sorry about that, 24,000. So next we need to find out what our density is. So we know what our volume is, and we know that our mass is 100. So now we're ready to use the density triangle. Cover up D. Your formula is mass divided by density. So that would be 100 divided, or by volume, 100 divided by 24,000. And that is going to equal 0.00417. So 0.00417. And that's all there is to it. So that is a two-step problem, but just know that anytime you're looking at the block to find volume, length times width times height, to give you that information so you can use the triangle for the rest of it. So let's go ahead and look at what's probably a lot of people consider the hardest problem on here, number 6. It's really not as hard as it sounds. So Sarah is making sweet tea. I love sweet tea. Her boss wants 3 pitchers of tea that all have different densities. Help her find the volume of each that must be measured in order to make the tea if each tablespoon of sugar has a mass of 5 grams. So again, lots of words. So what's going to make this easiest is if we write out our information. So we already know the density. The other things, it's wanting us to find the volume. So help her find the volume. So I know that V is going to be the question mark in all of these. So I'm looking for a volume in each of them. So V equals question mark. And it says each tablespoon has a mass of 5 grams. So for all of these, M equals 5. So I'm going to write that down for each one. M equals 5. So let's go ahead and first look at part A. So here we are just looking at the information for part A. We're wanting to find the volume. So if I cover up V in my density triangle, the formula I'm left with is mass divided by density. And if you do 5 divided by 2.03, then what you're left with is 2.46. So you would need 2.46 milliliters of tea to add to 5 grams of sugar in order to get a density of 2.03. So this would be your answer for part A. So I'm going to clear the screen and we can go ahead and look at part B. So TB, I'll go ahead and mark this out so we don't have to focus on it. The density is 3.45. Volume is, again, what we're looking for. And just like with all of them, the mass is 5 because each sugar, or tablespoon of sugar, has a mass of 5 grams. So same formula. If you cover it V, you're looking for mass divided by density. So if I do 5 divided by 3.45, then the volume I'm left with is 1.45. So that's how much liquid she'd have to add to 5 grams of sugar to get that tea's density. So that was your answer. Now let's look at part C. So TC has a density of 1.25. Its mass is 5 because that's what the mass of sugar is according to the problem. Volume is our question mark. Same formula. Volume is mass divided by density. So if I do 5 divided by 1.25, then my answer is 4. So it would have a volume of 4. So you'd have to add 4 milliliters of liquid or cups or whatever you want to look at it to 5 tablespoons of sugar. So the last part of Problem 6 is asking you which sweet tea mixture would be the most sweet. So there's a couple ways to answer this. Some of you may look at, if you're looking at how sweet tea is, you're looking at what has the most sugar. Well, we already know that each pitcher of tea has the same amount of sugar because all of them had a mass of 5. Because for each one she added a tablespoon, that was 5 grams. So we can't look at it just to see which one has the most sugar. Instead, we need to see which one has the most sugar compared to the amount of volume added to it. So if I give you a whole gallon of water and I only put 1 tablespoon of sugar, that's not going to be nearly as sweet as if I gave you a single cup of water with 1 tablespoon of sugar. So in order to see which one is the sweetest, you need to see which one has the smallest volume. And if you look, or if you remember your answers from the previous one, TB had the smallest volume. It had the smallest volume of 1.45. So the least amount of water or tea was added to the sugar here. So it had more sugar compared to the liquid, making it the sweetest. The other way you could figure out which is the sweetest is not even looking at the mass, not even looking at the volume, simply by looking at which one had the highest density. TB had a density of 3.45. Remember, the density is how much stuff is in a particular unit of space. The stuff we are looking at here is sugar. So it has more sugar per volume. So if something is more dense, it's more heavy, it has more particles. So the particles here are sugar, so it's going to be the heaviest in terms of sweetness, and it's going to have the most sugar particles per area of volume. So your TB is the sweetest, and you know that because it's the most dense. It also has the least amount of liquid compared to the amount of sugar. And if you have any questions on that, if that confused you or my explanations were not very helpful, I do have the written version of this up on Canvas, so you can take your time and go through it. But also please email me, or if you need to Zoom me, we can always set up a meeting and I can go over this because I know this was very quick. But be sure you know how to do these math problems for your tests coming up because you will see them. So again, let me know if you need any help.